This next unit we'll be talking about triangles. And triangles have properties that make them very useful in structures. If you look at the shelf on the right here, you can imagine that if you pushed it, it would sway a little bit. And so to keep it nice and rigid, you could add a diagonal piece, thus forming a triangle that would keep it from swaying. So very helpful shape. We'll be investigating a few things with triangles, so the supplies you'll need is one sheet of extra paper, a compass, a ruler, and a protractor. So if you want to go ahead and gather your supplies, you could pause the video while you're getting those. On your separate sheet of paper, use your straight edge to draw a triangle. And as we normally do, don't make anything special. Make a scalene triangle, and that's best for investigations. Write the letters A, B, and C in the interiors of the angles. Pause the video. Now that you have your triangle made, tear off the angles of your triangle and arrange them to show their sum. Think about the constructions that you've done to show the angle sums with your compass and straight edge. So pause the video while you arrange them and think about showing their sum. So this is my arrangement of angles to show their sum. I'm going to use this straight line to set them on. I'm going to arrange angle A and B. And I can turn angle C around to see if it'll fit right in there. Looks like it works pretty well on mine. Yours will not have the extra little edge that I had to cut out using the computer. So after you get yours arranged, go ahead and glue them on the line on your notes. And it's probably no big surprise to you that the three angles of a triangle add to 180. Just nice to be able to see that using our linear pair here. So you can add that to your conjecture, the triangle sum conjecture. The sum of the angles of the measures of the angles in every triangle is 180. Again, that was probably something that you already knew. So let's challenge ourselves a little bit more to try to figure out how that works for every triangle. Can we actually prove it or come up with a deductive argument why that works? So one way to do that is to add an auxiliary line to your drawing. So an auxiliary line is an extra line or segment that helps with the proof. So draw a triangle and let's add an extra line to it as we try to think about how we're going to prove that the angles of a triangle add to 180. So I'm going to use this top vertex and draw a line through it that is parallel to the bottom. And I have to use the computer's horizontal line, and so you can use the same thing with your ruler. I'm going to extend this one down. I'm also going to add angles. So I'm just going to call this angle 1, angle 2, and angle 3. So in my argument, I want to show that angle 1 plus angle 2 plus angle 3 add up to 180. So I drew this extra line here so that I could have two parallel lines. So let's add arrows to show that they're parallel. So you can do that in a proof. So we can say maybe this is line L and this is line M, and we can say let L be parallel to M. So it's like a given. So we're just assuming that that is true. All right, and added a want to show to my proof here because I want to keep in mind of what I'm trying to do. At this point, again, I don't know how to prove that, so I'm going to have to add some angles. Let's talk about angle, maybe call this one 4, and angle 5. You can always do that in a proof. If you want to talk about something a little bit easier, just number it or label it somehow so you can refer to it in your proof. Now go ahead and pause the video and think about how you could prove this. You might want to go ahead and try to write your own proof, and then you can come back to it and we can continue the discussion. Alright, I added to my proof since it takes me a little bit longer to type it. I know that L is parallel to M. I also know that 4 and 1 together, so if I think about these two together, and when I add those to 5, I get 180, and that's by linear pair. So I just put that I know that angle 1 plus angle 4 plus angle 5 adds to 180. It's not written really well. I should probably put the M in there, but I'm just kind of describing this, so I think it's fine. I could have also think about it as 1 and 5 added to 4 also makes a linear pair. So when you think of pair, you consider 2, but you could always put those two together. The other thing I noticed now that these lines are parallel, that I've got some congruent angles. So I know that angle 4 has to be congruent with angle 2 because those are alternate interior angles. They're on the inside of these two parallel lines, L and M, and here's my transversal. So angle 2 and angle 4 have to be the same. So I'm going to write that down. So I typed a little better with my measure. So I put the measure of angle 2 is equal to the measure of angle 4. Usually I'll add markings to my proof as I write it in there. So the reasoning behind that one would be by alternate interior angles, so AIA. Likewise, I know, grab a different color here, how about purple, that angle 5 is congruent to angle 3, also by linear pair. So I'm going to put 2 marks in angle 5 and 2 marks in angle 3 and write that down. Alright, I cleaned up my proof a little bit. I add the M's to the measure of angle M plus the measure of angle 1 plus measure of angle 5 because it's a better way to write it. And I know that the measure of angle 2 has to equal the measure of angle 4 by alternate interior angles. And likewise, I know that the measure of angle 3 plus the measure of angle 5 has to be the same, and that's also by alternate interior angles. And so I still need to get to where 1, 2, and 3 add up to 180, and I don't have that yet. So I want it to say 1, 2, and 3 add to 180, and I have basically 1, 4, and 5. So pause the video and see if you can figure out what the next line should be. Hopefully you've noticed that since 2 and 4 are the same, I could replace, where these 4s are the same, I could replace a 4 with a 2 and just put it right in there by substitution. I also noticed that since 3 and 5 are the same, I could get rid of the 5s and replace them with 3s by substitution. So let me do that. Instead of the measure of angle 4, since I know it's equal to measure of angle 2, I'm going to say the measure of angle 2 to put it in that spot. I'm going to keep the measure of angle 1 since it's already there and I want it there. And then I'm going to add that to, since the 5s are the same here and 5 is equal to 3, I'm going to replace the 5 with the 3. So all I'm doing is some substitution that you've done in algebra before. I'll scoot this up. Let's see what we have. Alright, since 4 was the same as 2, I put 2 in for 4. So I just replaced that right there. Since 1 was there, I kept it. And since 3 and 5 were the same, I put 3 in for 5 because they're the same. So my reasoning there is I just replaced, and anytime I replaced, I just substituted. So it's really the substitution property. I'm just going to type in by substitution. Oops, I didn't write my last part. They have to equal 180 by substitution. So we've actually just proved or shown that 1, 2, and 3 add up to 180 by substitution by adding our auxiliary line to show our angles. You can also use an auxiliary line to help you solve problems. So on this problem, we want to find the measure of angle ABC. Take your time to make sure you're finding the correct angle you need to find the measure of. So we want to find the measure of angle ABC, which we know is the least amount of rotation between those two rays. So we need to find this angle measure. We're not going to use our protractor because we're going to always assume they're not drawn to scale. So how could we do that? Go ahead and pause the video and see if you can figure it out. If you're successful, you can compare your answers when we get done here. If you had a hard time, you might want to try adding an auxiliary line. So I'm going to add a line that is parallel to the two lines that are already parallel. So you can do that in one step. I have to do that in two. So now I notice I've got some angles that I'm a little more familiar with. If these two lines are parallel, let me put an arrow there, then this angle right here and this angle right here are alternate interior angles. So now I know that this is a 75-degree angle. Type that in there. So that has to be 75 inside there. And I also know that these two angles, I'll use orange now, are also alternate interior. So I will add that measure in there. And now to find the measure of the entire angle ABC, which is all of the yellow, I can see all I have to do is add 75 and 45. So I know that the measure of angle ABC, try to type that better this time, is 120.